A parabola is defined as the locus of a point that is equidistant from a fixed point and a fixed line. This means is the locus of a moving point that is always at the same distance from a fixed point as it is from a fixed line. Let's use this to find the equation of a parabola. So here's our parabola. This is x-axis, this is y-axis, and this is our parabola. This fixed point is called the focus, and this fixed line is called the directrix. This parabola is the locus of all the points that are at the same distance from this point, that's the focus, and this line, that's the directrix. That's how we have defined this parabola. Let's mark a few points. Let's assume that the focus is at a, 0. This is at x-axis, so the y-coordinate of this is 0. Let's make the x-coordinate as a, so this is a, 0. This is our focus. This is our directrix. Can we use the coordinates of the focus to figure out the equation of the directrix? Let's try that. This is the origin, 0, 0. This is our vertex. Now by definition, this point that's on the vertex, it will be at the same distance from the focus as it is from the directrix. This means this length and this length are equal. This is a, this means this is also a. So moving a units to the left of the origin will give us minus a, 0. This means the equation of the directrix is x equals to minus a. Alright. Now let's use this to figure out the equation of a parabola. Let's take a variable point on this parabola. This is our point. We'll find the distance of this point with this line, the directrix, this length, and we'll find the distance of this point from the focus, this length, and we'll make these two equal. We'll equate them. That will give us the equation of the parabola. So let's join these points. So this length and this length, both of these are equal. Let's assume that our point is x, y. This is a variable point p, x, y. We're saying that because this lies on the parabola, it will be at the same distance from the directrix as it is from the focus. Now, what's the most convenient way to figure out these distances? Let's find this one first. The distance of this point from this line. Either we can use the distance formula or we can just measure the lengths. Because the coordinate of this point P is x, this means this length from y-axis to this point P, that's x, and this length, that's a. So if we add them up, this becomes x plus a. This means this point is at x plus a distance from this directrix. And what's the distance from the focus? For that, we can use the distance formula to find the distance between 2 points. That's square root of x minus a square plus y minus 0 square. So these two are equal. Let's equate them. This is equal to this. Now let's square both sides. We have x minus a square plus y square equals to x plus a square. Let's open the squares. We have x square plus y square minus 2ax plus y square equals to x square plus y square plus 2ax. Can we cancel a few things? Yes. X square cancels, a square cancels. We're left with y square here, and this 2ax moves to this side. We have y square is equal to 4ax. And that's it. We have just derived the equation of this parabola. This parabola is a rightward facing parabola whose vertex is at the origin and the axis is the x-axis. So this is our equation of this parabola. Now let's figure out the length of the lattice rectum as well. We defined the lattice rectum as this line segment that is perpendicular to the axis and which passes through the focus. Let's mark a few points. This point is the focus, so this is a, 0. This point is minus a, 0. Now to find this length, let's find the coordinates of these endpoints. What's the most convenient way to find the coordinates of this point? Well, we know the x coordinate, that's a. We need to figure out the y coordinate. This y coordinate will be the length of this part, the part that is above the x-axis, which is half of the lattice rectum. So how do we measure this? Well, we can observe that this is the distance between this point and the focus. By definition, they should be equal to the distance between this point and the directrix. So instead of finding the y coordinate, we can figure out this length. And what's this length? If this is a, this is also a. So this length is a plus a, that's 2a. This means the distance of this point from directrix is 2a. So the distance of this point from focus, which is our y coordinate, that's also 2a. So if this length is 2a, that's half of the lattice rectum. This means our lattice rectum will be 2a plus 2a, that's 4a. So using the definition of the parabola, we've figured out the length of the lattice rectum as well. That's equal to 4a. Now finally, let's look at all 4 standard parabolas. We looked at the rightward facing parabola, but there's also a leftward facing parabola as well. This parabola has vertex at the origin and it faces left. Then we have an upward facing parabola and a downward facing parabola. Pause the video, try to write the equations of all 4 parabolas. Alright, let's do it together. We have these 4 parabolas. This is something that we just derived. This is y square equals to 4ax. Here a is positive. The focus is at a comma 0 and x-axis is the axis of this parabola. This one is y square equals to minus 4ax. Here the focus is at minus a comma 0. This one is x square equals to 4ay, and this last one, downward facing parabola, that's x square equals to minus 4ay. So these are our 4 standard parabolas. This one faces right, this one opens to left, this one is upward facing, and this one is our downward facing parabola.